thank you very much for inviting me. And this year, so I thought to talk about more with fats, since several times I have been talking about proteins. So about fats is that the fats are very important source of many things that we need in the body. It's an energy supply, and it has a lot of I can't read what I wrote, but okay. So the fats they take a lot in the metabolism for many sources, for many as energy stored and they recirculate, but they are not. Well, we have to eat them in order to get the benefits. So the lipids, it depends on the structure as how we find. For example, they are, here we have saturated fatty acids, we have polyunsaturated fatty acids, we have cholesterol that can be also amphipathic. We have sterols that they are precursors of hormones, hormone synthesis. And we have a glycerol that they can combine to the fatty acids. So they can also combine with phosphorus for the phospholipids and the triacyl glycerols in the body. So the physical properties of fats, sometimes we say fats and we say oils, and we see that the difference is, it depends on the physical properties. So we have, we have the saturated fatty acids, since they are striped because all the carbons are occupied by hydrogen, so they become very solid. So we usually we say fat. So when the fatty acids, they have double bonds and they are polyunsaturated, so they become liquid. So the most liquid is the oil, is the most, they have most polyunsaturated fatty acids. So this is why we classify. So here we have an example of saturated fatty acid, which is striped. And here we have also polyunsaturated, that it can be bind in a different way, the double bond. It can be, so they get, depending the position, they can be cis or trans. So the fatty acids, the polyunsaturated fatty acids, so they can, if they are exposed to oxygen, heat, or pressure, they can become oxidized. And once they oxidize, so they produce free radicals. That free radicals, when they come to the cell, so they can become damaged. And so we have this problem with the oxidation. And what is important is about the oxidation, and is that we are now more trying to see the benefits or the not benefits of the fish oil, for example. So the fish oil is characterized with a large amount of polyunsaturated fatty acids. So those become oxidized more for the process. Usually the fish oil is produced by heat. So by heating the sardines or by heating the herring or whatever, and the press, so after the press is the extraction of the oil, so they have been exposed to the heat. So it's very often that they become oxidized. So how to choose an oil as a source to substitute the fish oil? So here, I don't know if you can see, I don't see, but you have the sections, sorry. We have here the section of the fish oil sources. So we have different fish oils, and you see the saturated, monosaturated, linoleic acid, alpha-linoleic acids, and what else? EPA, DHA. So here you have all the types. Those are from fish. These are from vegetables, and these are from animal fats. So we see here a gap that there are not EPA and DHA. So this is why usually we have not been using or substituting a lot of DHA of fish oil. But now the DHA becomes available through microalgae produced. And if you notice, well, here, sorry, in linoleic acid, here you can see. So now we will see what happened if you formulate with different oils. This in the red, so you can see the different, the amount of linoleic acid. And I must say, linoleic acid is a source of, is an omega-6. And omega-6, it has a problem that causes inflammation in the cells. So we have to avoid too much omega-6. So you see, most of the vegetable sources, they have a very high amount of linoleic acid. All soybean, or well, sunflower, and I don't read. I don't see. Okay, but then you have here the vegetable oils that with less linoleic acid are avocado, and there are olive oil, and here you can see the animal fats. So the animal fats, they have a very low amount of linoleic acid, and that promotes how easy it is to blend and to produce and substitute the fish oil in a more confident way. So this graph, I think, is a bit old, because I was told not many days ago that the fish oil now this year is cheap. This was done with the prices from last year. So the fish oil now in Peru, I think that the quota for fishery, the anchovy, it was much larger. So the prices, they become, I think, is almost half a price than it was a couple of years ago. But anyway, even with half a price, so we have to depending on the fish oil supply, it's very risky when you want to formulate as a regular basis. So considering the prices from last year of fish oil, so here we have the prices of the different sources of chicken and bovine and pork, and here you have the vegetable prices. Vegetable oils are still cheaper, but when you see the benefits of blending and the performance in the fish, then we find that it's much better to use the animal fats. But first, we have to think about the fish oil properties. So the fish oil properties, as we say, there is no doubt that they have a lot of good properties for the health, including so high percentage of the omega-3 fatty acids. So this is why for a lot of people, they denied or they refused to substitute the fish oil. But I think that with the prices and with the offer of different fat and oil sources available, so they become much better to be replaced. So formulating the ideal fatty acid profile, how to do it is the same as we do. Dr. Wu just talk about how formulating with different sources of protein, but it's the same with the fatty acids. So how not to formulate an ideal, and the ideal, it doesn't need to be exactly the same as the fish oil. So we have to think about more in the metabolism of the species that we want to grow to find out the best profile for substitution. So in the first experiment, so we decide to mix different fat sources. So we choose 71% of poultry fat with 25% of kernel from the palm, African palm. And then we add 4% of DHA extract. So if you can see, here is the profile of the fish oil, and here is the profile of the fat mixture that we choose. Here is the lauric acid. Well, I don't see, but I hope you see. But the lauric acid is a carbon of 12 carbons. And we thought that this could be a very interesting source of fat, because when the fat goes into the mitochondria for the respiration, so they need usually an enzyme to carry on the fatty acids when they are longer than 16 carbons. So the carbons from the fatty acids with 12 carbons, they just go through diffusion. So they don't need the enzyme. So we thought that we could spare some energy by giving this, and this doesn't have the fish oil. So this is why I say it's not exactly like fish oil, but it can be better. So we perform an experiment, and then we exchange the fish oil with our mixture from 0 to 5, and then that was in a shrimp diets. And here we have the fatty acid profile of the diet. You can see the lauric acid, the one that is with 12 carbons, is here. So it's higher than when you feed with the fish oil. And also, I would like you, if you look into the DHA, here is a microphone. No, it's not. DHA is here, is 3. So here, the DHA is much less than what it was in the fish oil. So one will say that why if you are saying that DHA is very important, why put it less? But then we see the experiment. Well, probably I don't know. Well, you see the experiment. The results is that we got much better growth. We got a better feed conversion ratio. And the third one. Sorry. Sorry? Hepatosomatic index. Thank you. So you see that the hepatosomatic index is, don't ask me what means the hepatosomatic index, because we have been doing a lot of research on that. So when it's too low or extremely high, probably it's not good, but we don't know exactly what means in the middle. What is the best hepatosomatic index in shrimp? So here are the results in figures, but it's the same as the graphs that I just showed you, but not only that is complete all the different. So in this we succeed that giving more lauric acid, so we spare some protein. So we did exactly the same with the tilapia. So we exchange the same mixture of fat. And here is the fat mixture, and is the profile of the fatty acids. And the results show that there is no much more difference. So we didn't reach the peak that as with the shrimp. So within here, there is no significant difference. So we thought that probably we were short in lauric acid. But here is the fat mix, the fatty acid profile, and you can see what I wanted to say. If we look into the DHA, here is the, where is this? Well, the point is that the DHA, it has the property to spare, or to hold in the body in a similar way. So what means why is better than in the fish oil? And it's because the oxidation. So I'm pretty sure that the DHA that comes from the algae, microalgae, it has a better properties per se. So we perform a next experiment with higher amount of lauric acid, just to see if we were short of lauric acid in the previous experiment. So here and then our fat mixture, it was with 50% of the palm kernel, and then we add a blend of poultry and bovine fat. So here we have the profile of the fatty acids in the diets. And here we have the results. So the results were not as good as we thought. So that means that probably the fatty acid, the lauric acid, is not necessary to add in higher amount, because when it is available with 12 carbons, probably the body send this fatty acid for synthesis of longer, so elongate fatty acid. So we have the samples in the lab, so we are going to perform some PCR to see if the elongases are expressed. And then also we were interested in the bovine fat. So bovine fat is a very interesting combination. See, if you remember, the linoleic acid is very, very low. So that means that we can combine. I can convince you to never use fish oil or never use plant oils, but we have to formulate with the ingredients we have closer. So if you use, for example, a vegetable oil, so in combination with the tallow, so it's wonderful, because then the amounts of linoleic acid they are going to be reduced. And also the bovine tallow, they have become known for this fatty acid. This is the 15 carbons, which is very unusual in animal fats. But since the ruminants, they have this microorganism in the rumen, so they are producing and synthesizing this 15 fatty acid with 15 carbons. So this is the fat that we use, that probably is too low, is lower as expected, but this is the one that we have available when we perform this experiment. And here then we made another experiment also with tilapia, and then we use this, well, we performed the experiment with this fatty acid. And here we have the well, you see that the linoleic acid is very low when in the last treatment. And this is ongoing. This is ongoing research. So then you can see the results here. But what is very interesting is the results that we got here. We got a better growth, not in the last, but we have an increase of growth. And the most interesting that we have now, sorry for my distraction, but let me say why we did this experiment in this way. If you see the ingredients, we press, because the C15, they said is a hepatic protector, and it's a cardiac protector, and it helps the cells to don't suffer the apoptosis so soon. So this is why then we press this trial with a very high amount of soybean meal. So this is a nutritional stress. So it's a tilapia that has been stressed by soybean meal, and then with this type of fat. So here, this is a very interesting result, because we increase the digestibility. So that means that probably something is doing something in the animals, in the tilapia. So now we have the samples going in. We took samples of intestine and liver for histology studies, and we are waiting also for the PCR results. So in conclusions, we can say is that a mixture of 71% kernel with DHA and poultry fat, it gives a very good performance of shrimp. And the linoleic acid is also decreased. And with tilapia, we can say that with a mixture of 71% with kernel and DHA and 71% of poultry fat, is a positive replace for fish oil without compromising the health of and the overall performance. However, if we increase the kernel, fail to improve the overall performance in all aspects. Well, in the highest concentration. And the use of bovine tallow is a promising alternative for aquaculture diets. And well, this is the ongoing studies that we are doing. We want to see then if the bovine, and also probably we are going to try to find or search more for the C15 in different sources and find out how variation is the C15 in the different tallow fats. And thank you very much.